Welcome and thanks for watching our session today. In this session, we'll be doing a thorough overview of real-time capabilities in the ArcGIS system, both in terms of the many parts of ArcGIS that offer real-time in one or few key areas, and also the broad real-time frameworks in ArcGIS. My name is Suzanne Foss. I'm the product manager for our ArcGIS Velocity and GeoEvent server at Esri, and I'm joined by Josh Joyner, who is the product owner for both of those products. Now, given the advent of the Internet of Things and the fact that roughly 80% of sensor data has a location component, there's a wide variety of geospatial use cases in the real-time customer base. Many of these use cases are horizontal, and they're applicable across different industries and sectors. So, for example, real-time data from sensors about employee locations can be combined with information about the immediate environment around them to help keep them safe, but also to gain insight from movement analytics to help optimize their work and allocation. And more broadly, businesses of all types want to be able to monitor, manage, and optimize their assets. And that's whether their assets are a fleet of vehicles or valuable hospital equipment that's instrumented and getting tracked. Many organizations also want to leverage contextual information to protect critical infrastructure. Historically, this has had to do with monitoring weather and disaster hazards and responding to isolate areas at risk. But it can also be more broadly looked at as threat monitoring and monitoring your infrastructure against any kind of external factor that could have an impact. Then there's geospatial IoT use cases that are more specific to different industries. In the utility space, there's SCADA integration and operations monitoring. In the agricultural and environmental markets, there's crop and air quality monitoring. And in transportation and local government, there's an increasing number of roadway sensor deployments to bring in data from connected vehicles. And municipal governments are looking to mine this data and understand micro traffic patterns. So the list of use cases with sensor data really goes on and on. In order to meet the demands of any of these use cases, software usually needs to have one or more fundamental real-time capabilities. The first is the ability to ingest real-time data. Real-time data comes from a lot of different sources, from an increasingly diverse array of systems, devices and sensors, IoT platforms, mobile device apps, third-party servers, and so on. Working with this data begins with integration and ingestion. So this isn't the typical user-driven ingestion, but a periodic or constant, always running process that is listening to a source and rapidly parsing data at the rate that it comes in. This gets increasingly challenging with increasing velocity and data complexity. After ingestion into the software system, in this case ArcGIS, as with any data, effective visualization is critical. For some use cases, the need is to have immediate fluid visualization as soon as data arrives. In other cases, drawing data on a repeated basis from a data source will show new information in what we call near real time. And as data is collected in real time, it can become voluminous very quickly. At that point, visualizing massive sets of observation data over time effectively is the true challenge. And for map-based visualizations, there's a number of methods that tend to get employed. Then there's analysis for real-time data. This takes several forms. True real-time analysis processes data as it arrives, and the ability to keep up with the data is a delicate balance of compute horsepower against the incoming real-time data, the static data sources that need to be used with it, the complexity of the analysis, and types of outputs. Like ingestion and visualization, there's also use cases where scheduled analysis is sufficient. And for traditional ad hoc analysis, asking questions about trends and patterns becomes an exercise in parallelizing and doing distributed computing, because often that's the only way to get it done with these massive data sets. And the fourth core capability for real-time is alerting. Another way to describe this would be more broadly taking immediate action. It can be argued that the main purpose behind any real-time workflow is enabling immediate action at the right place with the right resources and in the right way. And today there's many products in ArcGIS that have real-time capabilities in one or more of these areas, especially when supporting a specific use case. For example, there's several apps across the ArcGIS platform that collect real-time data from people's movements. Tracker for ArcGIS enables organizations to capture the location of their employees, especially when outside or driving, and store those tracks over time. Workforce for ArcGIS allows organizations to track their field workers while out on assignment and rebalance as task priorities change. Indoors for ArcGIS collects locations using a facility's indoor positioning system. And Mission for ArcGIS allows field workers coordinating on specific efforts to collaborate and communicate even in areas with low cell coverage. So let's look at one of these in more detail. With Tracker, like many of the ArcGIS field apps, different workers each would have the application on their phone, and it collects their location and periodically uploads the information to ArcGIS. This is captured in a central feature layer, the location tracking service, and it allows the organization to know where everyone is, but also to visualize and assess employee movement and travel using the track viewer. The phone app conserves battery by reducing the frequency of position collection based on how fast you're moving. And the track viewer is designed to optimize the display of location tracks with different symbology when a user is actively traveling versus staying in one place. Tracker is a useful solution for things like event situational awareness, proof of work for organizations that need to do frequent inspections, and also level of service commitments. In terms of real-time functionality, it has both ingestion and visualization capabilities. So that's some of the ArcGIS products that support real-time ingestion of data. Naturally, as a GIS platform, there's a huge number of apps for visualization, and some of these are the primary ones for real-time data. Dashboard for ArcGIS has for a long time been the real-time visualization app of choice, allowing you to easily trigger periodic refresh of maps and configure widgets to summarize data on a regular basis. And as we just discussed, Tracker's Track Viewer includes useful dynamic track line visualizations. Mission for ArcGIS allows both mission workers to see each other's locations and for the home office to maintain awareness of where all the workers are. And ArcGIS Pro has recently added broader support for real-time and big data visualization. Let's look at that briefly. ArcGIS Pro, as many of you know, is Esri's powerful next-generation desktop GIS. As part of its last several releases, the product has expanded support for visualization and analysis of real-time data, both when it's actively streaming and when it's accumulated over time. For example, for users leveraging stream layers from GeoEvent server or feeds from ArcGIS Velocity, you can now define unique renderers, class break rendering, and full symbology control. And similar capabilities exist for aggregated datasets coming from the spatiotemporal big data store. These can be viewed both locally in Pro or shared out as enhanced web maps, views, or feature layers. These new renderers, combined with the existing wealth of analytical tools, provide a really intuitive interface for working with data in real time and over time. Next in real-time capabilities is alerting, and both Workforce for ArcGIS and Workflow Manager fit in here. Workforce from the perspective of being able to update tasks and send them to field workers on the fly, and Workflow in terms of automated multi-step data management processes, which includes sending emails when key tasks are completed. And when it comes to analysis, there's many parts of ArcGIS that work well with time-enabled data, from Pro to Insights, and ArcGIS notebooks provide data scientists a familiar experience for processing and exploring data to build predictive models. GeoAnalytics Server is a key analytical capability for real-time driven data collections, since it can distribute compute to multiple workers and get jobs done faster. So as you can see, there's a rich tapestry of real-time capabilities in many parts of ArcGIS, and some solutions enable multiple parts of this for a single and specific workflow. Looking across all four of these fundamental pieces, however, ingestion, visualization, analysis, and alerting, the end-to-end solutions for real-time in ArcGIS are provided with GeoEvent Server and ArcGIS Velocity. GeoEvent Server and Velocity perform all of these different real-time capabilities, with an emphasis on integration with common sources of real-time data. They provide out-of-the-box diverse connectors for talking to different industry systems, parsing data in different formats, and turning it into ArcGIS features. Both products drive real-time and big data visualizations with the stream layer and the dynamic aggregation layers, and include alerting through email and text messages. GeoEvent and ArcGIS Velocity perform fully real-time continuous analysis on data as it arrives. Velocity also performs big data analysis on data collected over time through Spark operators, some of the same ones that are found in GeoAnalytics. The capabilities of GeoEvent and Velocity are agnostic, as opposed to being industry-focused, so they can be configured to enable any real-time or tracking workflow for vector data. In other words, they're the foundational real-time framework within ArcGIS. There's some differences between them, but primarily it's about deployment options. GeoEvent Server is for ArcGIS Enterprise, and Velocity is available through ArcGIS Online. More specifically, in ArcGIS Enterprise, GeoEvent Server enables end-to-end situational awareness, analytics, and alerting for data in motion. When data grows over time to large volumes, GeoAnalytics Server comes in as the solution to process that data efficiently over time. ArcGIS Velocity is in many ways the parallel to those products, but in the cloud. So it has GeoEvent's capabilities for real-time incident detection and alerting, and GeoAnalytics capabilities for big data summarization and analysis. With the rest of our time in this session, we're going to dive deeper on these two products, how they handle these different real-time needs, how they relate, and how they're different. Beginning with GeoEvent Server. And for that, I'll hand it over to Josh.
Thanks, Suzanne. I'm going to take the next few minutes to talk about our real-time visualization and analytics solution for ArcGIS Enterprise, the ArcGIS GeoEvent Server. GeoEvent Server is designed to help users gain deeper insight into their real-time observational data and help them make better decisions truly the moment something happens. And when we're talking about this observational data, this could be feeds coming from stationary sensors like stream gauges, air quality monitors, thermostats for that matter, anything where the unit itself isn't moving, but is continuously capturing data from its environment and streaming it out. Then, of course, there's the opposite of that, things that are moving, vehicles, people, storms, where the data we're most interested in are position, speeds, heading, etc. And finally, we have things that just happen, lightning, crime, social media posts, where we need to understand where something occurred and be alerted to it as soon as possible. So a 911 or 311 dispatcher gets the report of a gas leak. This is a new observation. And as soon as it gets reported, that might kick off a series of events we need to be monitoring for. And we're actually going to take a look at a demo of that very scenario here in a couple minutes. This software is one that runs in your environment, your infrastructure, which can be either in the cloud or on premises as a part of the larger ArcGIS Enterprise. And because it's something you host, it also allows for some great flexibility, allowing you to extend the core product with some add-on components available from download from our gallery, or for those of you with Java developers on your staff, you can create your own custom components using the bundled software development kit. We looked earlier at the breadth of Esri's product offerings that support real-time visualization and analytics in one capacity or another. But to provide a complete solution, there are several essential capabilities we need to support. First is ingestion. Again, this is fundamentally all about getting your data into these platforms. And because these data types can be vastly different, there's a wealth of schema controls and adapters to support almost any kind of vector data. Analytics. This could be as simple as filtering for a specific data type. Maybe I'm doing fleet tracking and I need to separate out garbage trucks from utility trucks. Or it could be more complex real-time analytics performing data enrichment on the fly. So we see those same trucks stop for an hour somewhere along the route. That's not supposed to happen. Maybe something broke down. Visualization. I don't need to tell you the benefits of visualization, but for real-time in particular, there are additional controls and methods that help support both lightweight feature rendering for moving observations and aggregation control for data that accumulates to massive volumes over time. Alerting. This is key for a lot of use cases. You have incoming sensor data detecting lightning strikes. You configure some analysis to detect field crews that are within a given distance, and you want to provide them notification or instructions to safely evacuate to another area. And we can send emails, text messages. And finally, one that wasn't on the earlier slides is storage. Sometimes you don't just want to do real-time analysis, but you want to leverage some other products like the GeoAnalytics server to look at data patterns over time. So having a way to store all of that enriched data is essential. At its core, what we're doing with GeoEvent Server is building out a pipeline. We're connecting to all these different types of data, pulling out what we need, hooking that up to a series of processors that add value to the data, and then connecting that out to something. So whether that's within ArcGIS or back out to some third-party system, we're giving you full control of your data.
So we're going to look at a couple use cases today as a part of these demos. And the first will actually be one that I think most users start with, which is asset tracking. That could be people, cars, shipping containers, anything that moves. And for the purposes of this demo, we're going to be looking at tracking utility vehicles and consuming a feed from an AVL system, an automatic vehicle location system. So the first thing we need to do to get started is click on Add Service, and we want to give this a name. This is our real-time analytic we're configuring through the GeoEvent application. We need to configure some different components. First is our input. Where is the data coming from?
If you already have your data within ArcGIS, you can use this input here, which is pull on ArcGIS server for features.
Maybe it's coming from a file, a CSV or a JSON file. But more often than not, it's coming over the web. So maybe we want to connect to some external website for JSON or XML. Or we want to expose a REST endpoint for some sort of third party to push data to us, which is what I'm setting up here. So it's pretty simple. We come in, we give it a name, we give it the name to our definition or the schema. If there's any advanced settings we need to do, we can configure those. But for the most part, you can take the out-of-the-box settings. So the next thing we need to do is configure an output. What are we going to do with this data once we bring it in? Just like before, we have options to do add and update. We can send it out to a feature service. We can send to a stream service. We can push it out to WebSocket. But for the purpose of this demo, we're just going to do a local export, which is a TCP socket, just kind of a dummy output so we can configure some stuff here and take a look at how the components work together. So the first thing we want to do is we can turn it on, make sure we actually have data flowing, which is always important. And then what we can do is we can actually look at a component. This was introduced as a part of the 10.8 release. This is the GeoEvent sampler. So this allows us to actually see the data in real time. So we can see here we have some timestamp, a vehicle ID, some coordinates, not much more to the data. If we want to visualize it, we also have a built-in lightweight mapping client, so we can kind of see, okay, we got 5 different locations here, and a couple of these have multiple observations for them. We're getting updates about every 2 seconds. So in this case, we have the same vehicle with 2 updates. But outside of that, it's not the most useful data. It just tells us kind of the vehicle name and where it's at. To get more use out of the data, we could do some additional processing. So in this case, we're going to deploy a processor called the Field Enricher. This basically allows us to do kind of a lookup table. We're able to take the data coming in from the sensor and enrich that against a feature service layer we've published. And that feature service layer has information about the crews driving the vehicles, their name, their telephone, email, the name of their supervisor, etc. We're going to pull all that data in, joined against the vehicle ID. So we're going to match up the vehicle ID of the incoming data with what's stored in kind of our lookup table feature service. And as new observations come in, we're actually going to be creating kind of a new schema, new definition of the data that includes both. We can clean up the layout of the table here if we want. We get data started. And we can actually take a look at this as well. And you can also do a comparison view. So we can see the data coming into and out of this processor has some additional fields to it. So now we can see, instead of just having position, we actually know the name of the driver that's driving that vehicle. And this is information which we can then use to perform a series of analysis from there, now that we actually have some more data about it. If we want to see a slightly larger sample size, we can do that. We can select a sample size of 100 messages. So we're going to kind of turn this feedback on. We're going to wait till we collect 100 messages coming through. Just another second or so here. And we can visualize that. And we'll see now we have quite a few more observations on a couple of these. So we have about a dozen or so of this one vehicle. Looks like it's driving down a highway. And we can synchronize the base map so we can kind of make sure we're looking at the same ones both before and after the enrichment. We have another one here of a driver going through a neighborhood, going a little bit slower as the observations are a little bit closer to each other. If this were going out to a feature service, we could just start this output immediately and it would continue to flow. Or if we wanted to do a little deeper enrichment with it, we could send it through an additional series of processors. Maybe we want to send it through a filter. Maybe we want to look for vehicles that are speeding. Or maybe we want to do something like an incident detector, where we're concerned about speeding, but we're more concerned about speeding when it's inside of a residential neighborhood. Or we're concerned of how long they were speeding for. You can build these models out as complex as you want to provide the type of real-time analysis you want to provide. So for the second demo, we're going to look at some data that is not moving. We're actually going to look at some citizen request data coming in. And we're going to take the role of kind of a utility worker dispatcher. Someone's reported that they smell gas near their office. And this is something that, there'd be normally you'd file a work request, but we're actually going to try to automate some of this process. We're using an add-on component here called the field enricher, but for a spatial query. So we're going to do a spatial join against the position of those the homeowner or the resident that reported the smell of the gas leak. And we're going to join that to a feed of weather stations. So what we're going to pull in from the weather stations is we're actually going to pull in the name of the station, wind direction, and wind speed. And we're going to join that to the closest weather station within 10 miles. And the reason we're going to do that is we want to be able to see if we can detect where we think this gas leak is coming from. So we brought that in. Next, we're going to set up an output again. Again, we have to have some output. It's got to go somewhere. And we can publish this just to take a look at what the data looks like. And we'll get this started here. Just a moment for it to come through. All right, and so we can see we have some information we can kind of organize, make a little nicer looking here in the service designer. Quite a few fields. This is, of course, a service request coming in for utility repair. Resident reported the smell of gas. We can stop this. Sorry, I had to get that started first. I apologize. All right, so we can take a look, and after the join, we see it was able to join to a weather station here. We've been able to detect the wind speed in kilometers per hour and a wind direction. So we're going to add some additional processors here. In particular, we're adding a range fan and a field calculator. And with the field calculator, we're kind of inverting that direction the other way. So we want to know where the wind is coming from, not where it's going. We can also see here what this range fan is doing is actually creating a forward-facing arc. So instead of a normal buffer that goes all the way around, this is a buffer in a given angle. So what we're looking for here is we're taking this point observation where someone said they reported smelling gas, and we are kind of creating this range fan to show where potentially that's coming from. The next thing we can do is we can take that same polygon we've now created, and we want to compare that to some stored geometry. This is what we call geofences. And with geofences, we're able to import here the list of some of the known gas inspection locations in and around this city. From here, what we'll do is we'll deploy a geotagger processor. And what the geotagger processor will do is it's going to do kind of a spatial join, but it's really detecting, is there some intersection with this new geometry we've created and the stored geometry that we've already brought in. That's those gas inspection points. And what this is going to do is it's going to create a new field within our definition that'll kind of contain the name of that inspection location. The point being, so if we're able to detect a station, we are able to detect a inspection point that is in that range, that's where we'd likely want to send our work crews to, instead of necessarily sending them directly to someone's office. So we can disable this while we make the changes to the service, disconnect our existing pipelines, hook this in, publish it to save the changes. And if we want to adjust it just to make things fit a little better on the screen, we can do that as well. If you do make changes to the kind of the layout, the styling of the model, you do it to publish again just to save those changes. But now we can kind of clear everything, start the input flowing again. And we can also do a comparison. We'll wait for the next report to come through here in just a few seconds. All right, and excellent. And so you can see we're able to identify the location of that potential leak spot. So now we have kind of at least a starting point for our field crews to go out to. And from here, we could choose to send it to the output like we have set up here. We could send email or text output. We could even look at setting up something through Workforce Manager because we want to be able to create a work order of sending these crews. The goal being at the end of the day that we can take these tools, we can build out these real-time analytics and build value to the data. It's not simply ingesting it. It's not just bringing data into the system. It's not just visualizing it. It's truly doing full end-to-end analysis on this data in real time.
But GeoEvent Server is not the only product we have that can do that. We actually have a second product, ArcGIS Velocity, And for that, I'm going to hand things over to Suzanne, who can talk to you a little bit more about that offering.
Thanks, Josh. So ArcGIS Velocity is a newer capability that extends Esri's geospatial cloud, ArcGIS Online, with real-time and big data functionality. First, it provides a wide variety of capabilities for ingesting and working with observation and sensor data. You can configure out-of-the-box connectors to bring in data from IoT platforms and third-party APIs, so a big parallel to GeoEvent server there. ArcGIS Velocity is also an end-to-end system for analysis, supporting analyzing data in real time in a streaming way, in near real time with scheduling, and also over time. And then thirdly, you can take immediate action as a result of your analysis, sending notifications or triggering downstream processes. At a conceptual level, ArcGIS Velocity sits on the edge of Esri's geospatial cloud and complements Internet of Things platforms by enabling you to easily bring sensor data into ArcGIS for spatiotemporal reasoning. So as sensors are being deployed out in the field, they're increasingly being onboarded and connected up to IoT cloud frameworks like Azure, AWS, and Google IoT. Velocity can subscribe to or query many of these platforms directly without requiring developer integration. And sensors could also drive data directly to Velocity, for example, over a REST endpoint. The capabilities of ArcGIS Velocity are surfaced through a few new types of items in ArcGIS Online. Feed items allow users to receive sensor inputs. They're these user configurable components that make connections to real-time data. Real-time analytic items allow users to perform real-time processing of those inputs, including triggering alerts and actions. And with big data analytic items, users can access and analyze big data repositories of observations that have been collected over time. These analytics can generate geospatial content like stream layers, feature layers, and map image layers, which can then be leveraged throughout the ArcGIS system, in client applications, in APIs, or in desktop applications, all to drive additional insight and situational awareness. So let's take a look at how ArcGIS Velocity works with some examples from one of our beta participants, which is the California Department of Toxic Substances Control. The California Department of Toxic Substances Control has a mission to protect Californians and their environment from exposure to hazardous waste. And like many states, there's thousands of industrial and manufacturing organizations that generate toxic substances. Those are shown here on the map in orange. Toxic substances include things from iron and steel production, lead processing, and so on. One of the department's responsibilities is managing and monitoring the transport and disposal of hazardous materials at approved waste facilities, which are shown here in green. But today, the substances control staff only receive high-level manifest information on hazmat transport, which is what these lines represent. They get information on where the waste came from and when it left the generation site and when it got to the destination, disposal, or storage facility. The challenge for the department is that this from-to information doesn't include the actual routes taken by the trucks, and therefore it doesn't illuminate where waste might be traveling through local communities. We collaborated with the Department of Toxic Substances to explore the capabilities of ArcGIS Velocity to track hazmat trucks. After creating a simulation from historical manifest data, ArcGIS Velocity was used to ingest that data stream using a feed. You configure a feed using a guided experience based on the system where the data is coming from, whether it's an IoT platform or a web and messaging broker of some kind. There's a series of steps to provide the connection information, which samples the data and allows you to adjust the data model, and then to identify properties like geometry and time. And once it's running, a feed can be added to a web map to immediately visualize incoming information in real time. Feeds leverage Esri stream layer technology to push new information to the map immediately. So you can see in this example the subtle movements of the trucks that are being simulated here. Now, hazmat trucks are not currently equipped with onboard devices to report position, but using the data simulated that was generated off real trip history, this allowed the department to test the performance of ArcGIS Velocity and how it can handle thousands of data points per second. Next, we worked with the Department of Toxic Substances to explore how this type of data could be used from a risk monitoring perspective. A real-time analytic can operate on each message as it arrives, transforming, enriching, and performing geofencing and proximity analysis between sensor readings and areas or locations of interest. So this is a representation of how a real-time analytic would calculate distance on the fly to nearby features. Now, in monitoring hazmat trucks, the Department of Toxic Substances is interested in understanding when hazmat transporters get too close to what they call sensitive receptors, which is schools and hospitals. And there's over 10,000 schools and hospitals in the state of California. In ArcGIS Velocity, we configured a real-time analytic to do this. This analytic operates on the feed of the hazmat truck positions, leverages a feature layer of schools and hospitals as geofences, and performs a distance calculation for each truck position against those locations within a given radius. And if a school or hospital is within that radius of the truck, it's considered too close and an incident is reported. In this case, the incidents are visualized in another stream layer, which in the map are the locations with the yellow flag symbol. So in this example, the simulated truck was too close to an elementary school. Incidents like this can also be used to send a notification, like sending an email or a text message. So these are just a few simple examples of how ArcGIS Velocity can be used to ingest and act on real-time information. So let's walk back through these pieces from a conceptual perspective. Feeds bring in and visualize real-time data, and they can be used in real-time analytics for immediate awareness of incidents. Real-time analytics can also store observations over time to a feature layer. And as data arrives in real time, these historical data sets can grow to large volumes extremely quickly. Even just 250 messages per second grows to 20 million records within one day. For that reason, Velocity is designed to grow with you. It includes fully configurable big data analytics so you can process this information for trends. And these big data analytics can be traditional ad hoc analysis, but they can also be scheduled and run in near real time to support different workflows. Now, both types of analytics in ArcGIS Velocity can generate output layers for visualization of time-enabled data. And there's three basic types. Stream layers visualize new data right as it arrives. Here we're looking at city buses moving around on their routes. Stream layers are based on WebSocket technology, so the map is actively connected to the underlying real-time server and stream of information. Feature layers visualize data once it's been stored, and of course they're the most common layer used in ArcGIS. To visualize data from a feature layer in near real time, you can set a refresh interval. And that means that the layer requeries information from the data store every few seconds. Now, when you store data to a feature layer using an ArcGIS Velocity real-time analytic, like GeoEvent server, it also creates a special kind of map image layer. This supports dynamic aggregation of high-volume data, which means that you don't have to try to draw millions of features individually. Instead, it draws on-the-fly aggregations that refine continuously as you pan and zoom, showing you increasing levels of detail, and it transitions over to raw features when you have a reasonably low enough number of features in the map extent. So all three of these layers can be created through analysis tasks and then used in apps and dashboards to visualize information and improve situational awareness. And if all of this sounds very familiar to what Josh was going through with GeoEvent and also in general to GeoAnalytics, that's because it is very similar. ArcGIS Velocity is a parallel to GeoEvent and GeoAnalytics, but it's part of Esri's geospatial cloud. So for example, in GeoEvent server, ingestion is configured using what we call an input. In ArcGIS Velocity, the equivalent is the feed. A feed also goes a little bit beyond a GeoEvent server input because, as we've shown, it's a type of stream layer, and it enables you to immediately visualize your data on the map. For analysis and alerting, in GeoEvent server, you would combine inputs, tools, and outputs in a GeoEvent service. And in Velocity, this is called a real-time analytic. In both products, these are the analytics that perform continuous processing. And thirdly, in GeoAnalytics server, you would run ad hoc analysis on large volumes of ingested data using an individual GeoAnalytics tool, whether you run it from the server or in desktop, and you might also write a script to string multiple steps together. In ArcGIS Velocity, you can connect the same tools together into a single process with a big data analytic. And these use the same visual model building environment as the real-time analytics, meaning you can automate big data analysis without writing code. So to wrap it up here and just reiterate, today ArcGIS Velocity is a configurable real-time and big data engine for ArcGIS Online. It extends ArcGIS Online with the ability to easily bring in real-time data from different platforms and put that data to immediate use. And there's three primary capabilities of Velocity. The first is ingestion of sensor data with wide support for different messaging systems, data formats, and data velocity. The second is to automate analytical processes and tradecraft on that data, whether you need to automate and run that analysis in real time, in near real time with scheduling, or massive amounts of data over time. And thirdly, to drive specific action from analytical results, such as alerting. This is all configurable with familiar and powerful spatial analysis tools and can be applied to use cases from personnel tracking to asset monitoring to infrastructure protection. So with that, we'll close up with a few key notes and summary points, and I'll hand that back over to Josh.
Thanks, Suzanne. As we start to wrap up, there's a few points I want to touch on briefly again. In terms of product offerings, providing complete real-time visualization and analytic capabilities, we have GeoEvent Server and Velocity. In many ways, these products have comparable functionality and are just different deployment options, but I wanted to review some of their differences side by side in case you can't decide which option fits your needs. GeoEvent Server is your traditional software product. It's installed as a part of the ArcGIS Enterprise in your infrastructure. If you need to include big data analysis as a part of your solution, you can also opt to install the GeoAnalytics server, providing additional insight into the data you've collected over time. In contrast, Velocity is a capability of ArcGIS Online. It provides many of the same capabilities as both GeoEvent Server and GeoAnalytics Server in an offering that is fully managed by Esri. And because of that, it doesn't need a GIS admin to manage it, whereas GeoEvent Server should be considered an advanced admin level product, particularly in terms of the necessary GIS/IT controls to support access to external feeds or different secure data streams. However, because GeoEvent Server is something that can be installed offline or in closed and secured environments and is fully extensible, it allows you to expand its functionality beyond the core product, and that's something a lot of customers need. Velocity runs in a secure but public cloud infrastructure, so it supports feeds over the internet. And because the architecture is designed from the ground up to be cloud native, it can provide far greater scalability and resiliency over traditional software options, supporting higher velocities and volumes of data than what's available with GeoEvent Server. Both products have full end-to-end control, providing solutions for your real-time visualization and analytic needs. It just comes down to what other deployment requirements you might need to consider. If we step back to the larger suite of product offerings that support real-time across ArcGIS, you'll find it's an ever-expanding field of solutions. Many of these can serve as standalone components, providing focused solutions for specific real-time needs. Others build upon each other, exposing far greater functionality when paired together, like the GeoAnalytics Server or ArcGIS Indoors and GeoEvent Server, or Pro, enabling far greater visualization controls over feeds that were created in Velocity. The landscape and fundamental concepts behind GIS are shifting as real-time continues to play a larger role. And that should be immediately evident just based on the number of products and teams supporting these new paradigms. We hope this week you had a chance to attend some of the other dedicated sessions on these products, and you can take a deeper dive into their functionality and how they might help you solve some of your real-time needs. If you have any questions regarding these products, please feel free to reach out to either Suzanne or myself, and we'll do our best to answer them. Also, please take a few moments to provide your feedback for this session by clicking on the survey link below. Thanks a lot.